Good evening, folks. Welcome to another episode of vBrownBag. Tonight we are trying a couple of new things. Mike has asked to turn the cameras on. So yay, this is what I look like, and this is what Mike looks like. I've been listening to Mr. Kennedy's voice for the past year because of his amazing Python podcast. I'm sure that he's going to talk about that a little bit, so I won't steal his thunder. This is actually the first time I've seen what Mike looks like too. So good evening, sir. How are you today?
Yeah, good evening. It's super to be here. Thanks for having me. I'm looking forward to sharing some of this cool Python stuff with you all.
Awesome. Okay, so tonight is going to be a continuation of the Python for DevOps series, talking with Python developers and learning how to level up our skills. And do we have a guru for you tonight? Michael Kennedy is like I said, he's a podcaster, he's an instructor. I highly recommend. Actually, I did recommend it already at the beginning of this entire Python series. I mentioned that he is one of the resources that I've been using to teach myself Python this entire time, even back in the day when I didn't know. So when I first started listening to the podcast, I literally only understood 1 out of 10 words. But I cherry picked the podcast where he was talking to educators and he was talking to people that were teaching other people, and I wrote copious notes down. I learned I picked up all of the resources that those people were using, and I've passed that information on to our listeners. And now I have the man himself. I'm highly excited about this. Yay!
It's wonderful to be here. Thanks.
Cool. So with that, tonight we're going to be using Python's async and await to boost DevOps, presented by Michael Kennedy. As always, please get in on the conversation. If you @ vBrownBag or hashtag vBrownBag, I will be paying attention to both. If you are in the live Q&A audience, I will also be fielding the questions from in there. And let me make sure that I've got my system set up. Yep, I can see everybody from both Twitter and there. We also have the vBrownBag Latam and vBrownBag EMEA channels. With that, tonight, my guest is Mr. Michael Kennedy. He is @ mkennedy on Twitter. I highly encourage you to follow him because he's always got some good stuff on there. I also encourage you to listen to his podcast. Mr. Kennedy, are you ready to take the reins?
I'm ready. Let's do it. Let's talk Python.
All right. I see what you did there. That was a good job. Cool. You have the power.
Here we are. Super. Let me move that to another screen and maximize this thing. Promise there won't be a ton of PowerPoint, but I do want to set the stage. Chris, can you see the screen all right?
Everything I can see it perfectly. Yes, sir.
Super. All right, let's get going. So as Chris said, the idea is we're going to look at some advanced features for helping DevOps in Python, but I don't want that to scare you because I think these features get a bad rap. They can be put together in a complex way. They can solve complex problems, but as you'll see, they also solve problems very simply, very powerfully. So we're going to talk about that. Quick intro, I guess it's already put on the screen. It's going to come up anyway. My name is Michael. Follow me on Twitter. I created Talk Python Training and run 2 podcasts, Talk Python to Me and Python Bytes. All right, setting the stage. Let's talk about some opportunities for using not just Python, but the async capabilities. Async being the ability to do stuff in parallel at the same time. And I just came up with a couple. I'm sure there are many, many more in the DevOps world that other folks could contribute to the conversations here. So first of all, if I'm going to use something to talk, say, over SSH to a server, maybe I would use Paramiko or some tool like that. You know, that can be slow. I'm going to go talk to the server. I'm going to make a SSH connection. I'm going to issue commands and wait for it to respond. Maybe those are, you know, apt install this thing, which takes 10 seconds. If I have to do that for a lot of servers, it would be way more useful to talk to them all at once and only wait for the maximum time of any one server, not say 20 servers, right? So here's an opportunity for using what we're going to talk about. Do you need to generate reports or parse logs on multiple servers or multiple websites, even with different logs? All right, here's a place where we could reach out to different locations and gather this all up and generate these reports, potentially much quicker. If you're working with routers and switches, you know, there's APIs to program those. A lot of times they have Python libraries for talking to them, But if you're going to talk to a bunch, again, right, you could do that in parallel. Could be a lot better. And what I'm going to talk about specifically for our example is I'm going to focus on websites, and something everybody who is in charge of a website, touches the website some way, oddly using DevOps to make it rank higher in Google, okay? And also to give users a better out-of-the-box experience for new deploys. So that's what we're gonna focus on. Here's just some of the opportunities that gives you a sense of where it might go. Now, before we get into what we're actually going to do, what I'd like to do for us is to set the stage and just talk about async and await in Python. Like I said, this can feel like a complex thing, but in fact, there's very small changes. It used to be that parallel programming and asynchronous programming in Python were super, super tricky. However, since Python 3.5, which is a couple years ago now, they've had a couple of new keywords that make writing parallel code and just normal code that just did it one at a time almost identical. Okay, so we're going to talk real quickly about that, and then we'll come back and see how we might apply this to DevOps. So let's go over here. I have this code, and all this code you see here, you'll be able to get and take it with you. I'll link to that here at the end, so please be patient for that. So let's look at this little program here. I'm going to show you a version that is the traditional version. I'm going to call it Sync Web, and I'm going to show you a version called Async Web. So I came up with some arbitrary example here for you just to give you a sense, but it's real. It's going to a real server. It's actually crossing the entire distance of the United States. It's landing much closer to Chris than it is to me. So I'm on the West Coast of the United States in Portland. The server we're going to be talking to is in New York City. All right. So if we're going to go make requests out to the server, right, the ping time from here to there is close to 100 milliseconds, just the nature of the internet. And then it has to process the data and get back to us. So it's a little bit contrived, but what we're going to do is we're going to just go to my podcast, Talk Python to Me, and we're going to get the title of each episode. Now, I want you to put aside the fact that there is an RSS feed. I could pull it down and actually analyze it. The idea is just to go to a bunch of different web pages and pull some information out. So we're going to go to random episodes, 200, 215, whatever, and then we're going to use this library called requests, and we're going to just get that URL, and then we're going to return its text. And then we're going to use a really cool library called Beautiful Soup. And Beautiful Soup can take the HTML, understand it, and then lets you ask questions like, give me the H1, which is the main title, or find me all the things with this class, you know, find me all the images or all the links. There's all kinds of interesting stuff you can do. So we're going to run this bit of code against it, and it's going to return just the text value, the compressed text value without like the white space of whatever the title of that page is. And then we're going to do that for, you know, pick some arbitrary range of numbers. Okay, 215 to 228, right? And, you know, be kind. Just like this script itself won't actually hurt my site. It can handle it, but the one we're going to write next could do some damage. So don't do that. All right. Now let's go ahead and run this. I'm going to make sure I run the right one here. This is PyCharm. This requires some requirements, hence the term, I guess. You need to pip install these things here just to make sure you have Beautiful Soup, Colorama, because everything's better with color, and then request. This stuff is what we need for the, whoops, go back here. This stuff right here is what we need for the first version, and then you know, we're going to need some slightly different libraries that support async and await. All right, with all that set up, let's go make, what is that, like 13, 14 requests over to the server, get the titles, and get it back. And also, notice we're getting the time out here. We're saving the time at the beginning. We're doing a little calculus here, getting the DT, and we're going to print out the DT.total seconds, however long it takes, okay? So let's run this puppy. So there it goes. You see it's getting episode 215. It got it done. Then it goes 216. Then it goes 217. Then 218. The server actually can handle a ton of concurrent requests. That website gets millions of data-driven requests per month. It can totally take it. So but our script is not taking advantage of that. Just on the ping time alone, we're wasting 100 milliseconds for every one of those numbers, right? And if we're doing 13, that's 1.3 seconds to save just by like ignoring that. Forget whether the server can take it, right? So it would be much better if we could do this at the same time. If what we could do is say, I want the episode for the title, the content for episode 215, 16, 17, 18, 19, 20, all of those. And when you got all that, you give it back to me. And then I'll start going through it, right? And then we only have to wait ping time plus the longest request, right? So that would be really nice. I'll just run this one more time so y'all can appreciate it slowly creeping by. And see, it's right, like it's, you know, serverless programming, interactive graphs with bokeh, maintainable data science, tips for non-developers, right? It really is going to the live website and getting that data, which is awesome. Like already this script is super cool, but it could be so much better. So let me show you how we can make this little thing better over here. We're gonna make smallest of changes. And if we go over here, let's look at this one. Let's get HTML. Remember we were using requests, we were calling request.get, and then we're getting the text. Request does support async and await. It's been kind of on the roadmap forever. Doesn't have it, not a huge deal, but we have to use a different library for that reason. So there's this thing called AIO HTTP, and it has this client session we can create. You could also have the same style of code with request. Request has a simplified just get method. So what we're going to do is normally you would write this. Let me take this away.
So before you hit go on the next bit of it, I'm going to
write this, and this will successfully give you that code. Now, this library, it won't work because of the way it works, but if this was a request, this was what you would write. Go over there, create a session, get the thing, make sure it didn't 404 or something, give me the text, and give that back. All we got to do is sprinkle on some magic little async dust, okay? So what we can say is we want this library to run asynchronously. So one could get started, and if we don't wait for the answer, we could start many more, and they'll all go on what are called IO completion ports, just waiting for the IO, the network IO to complete. So it doesn't actually even create additional threads or overhead in that sense. It's just using the networking layer to like resume it, basically. Okay, so what we do is we say this stuff where we're working with the network, we now want this to be asynchronous. And when we get the values back, we have to write await, okay? That takes this thing that's running and it turns it into HTML. Now, this alone is like standard Python's async model. There's this other library called Unsink that just makes a lot of the stuff you got to do to get it started and keep it running just go away. So Unsink is a beautiful library. I'm not going to go too much into it because we just have half an hour. I want to have some time for what we're really doing, but you should definitely check it out. All right, so what we're going to do is we're going to be able to asynchronously get this HTML, and instead of going one at a time for each URL getting it, we're going to go, actually, what did I have? I had 213 to 228. There we go. Got to keep those the same, or it doesn't quite mean the same thing. So we're going to go through that number, and we're going to start a request for 213, 214, 215, 216, start them all, forget whether they finished, even if they haven't even made it out of my machine, out the network layer, they're started. And then we're going to go through and say, wait till the first one's done. Maybe the third one finishes first, and then the fifth, and then the first. Doesn't matter, just we're going to wait for them basically all to be done. So we're doing that. I'm going to print out the title again. Are you ready? Let's see the difference. All right.
All right, this
so what you should see
might hurt your audio and video, Mike. Just a FYI, when you turned off the last one, it kind of flushed for a second. So
it did. All right, let me go ahead and stop my webcam for now, and I can bring that back later. So yeah, this is probably going to hurt it more, but what it's going to do is it's going to start all the requests, and then it's going to get all the answers, not waiting for any of them. Ready? Look at that. Boom, all of them started. There's all the answers.
Nice.
That's a little over 1 second. Let me do it again. Start them all. Wait for them to finish 1.09 seconds. So almost 10 times faster. And that's because we're hitting the same server. If these were fanned out to different servers, of course, it would be even faster. But I mean, we're really speeding this up. There was a story someone told when I talked about this library and this technique that they had some job that would run for like 12 hours, and they applied this technique, and all of a sudden either their laptop or their server started crashing, and the reason was they were running out of memory. They were getting HTML so fast they couldn't handle, and once they finally got it tamed, it went from like hours to 30 seconds or something ridiculous like that. So this is super, super powerful, but the idea is we can use this very simple pairing of keywords, async and await, to take what would otherwise be like normal code and turn it into parallel code, right? Super, super nice thing. Now, how does this tie back to DevOps? Well, anything that you want to do, any of the examples I gave you are reasonable candidates for running this style of code. And some of the core libraries support using async directly on them, but Unsink has a fix for when that's not true. You can even say CPU, I think it's CPU bound, like that spelling is true. And then it will actually use multi-processing to automatically, like behind the scenes, make CPU bound work true. If you actually can't write an async method, this will run it on threads. This Unsink library is beautiful. But the core idea is we want to use the async capabilities to talk to our server here. And in this case, we're just doing web scraping really fast, right? That's pretty interesting. But let's put that away for a minute and come back here.
Quick question.
Yeah, go for it.
Can this lead to any kind of race conditions?
It should not. You know, it depends on like the website you're talking to. The website itself is probably built for concurrent visitors, right? Like it's got to be, if it's any sort of production server, it's built to take it. So then it gets down to what are the race conditions that you might hit in your code? And what's interesting about async, not with the CPU bound is true, like forget that for a minute. But when it's like this, these regular async methods, there's only one thread. There's never actually any more than one thread. And
okay.
Which is really, it's really counterintuitive, because you think I'm doing parallel stuff, so of course I'm creating processes or threads or whatever. It's actually not doing any of that. It's just dumping a bunch of stuff on the network and then figuring out how to handle the responses as they come back, as the IO gets completed. So hence the Async IO name, right?
I see, okay.
So there is a danger of it, but it's much smaller because you're not actually doing threading. I mean, you probably could get yourself into some sort of situation if you wanted to say, could I come up with a scenario where there's some kind of race condition? Possibly, but like I said, it's much less common.
So I think you actually just answered the second question that came in. How does it use multi-CPU if there's only one Python interpreter available? The answer is it doesn't.
It does. It does not. Absolutely does not. Now, Unsink is a bigger library than async and await. If you say CPU bound equals true, then those do run as separate processes, and the OS will map those over to different cores and so on. But Async IO and the async and await direct stuff doesn't work that way.
Gotcha.
It literally does. It's only, like, hence the name IO in the library that makes it happen, right? It's not for CPU stuff, for IO, when you're waiting on other systems, databases, web servers, network, whatever.
Cool.
Cool.
Thank you.
All right. Sure. So now let's move over to our next thing. And here's something I'm actually using day to day that I think is pretty interesting. Let me really quick just sort of summarize. So here's yeah, the welder's built. Hopefully that's the building, right? Okay, so if we're going to do this, we have async in certain places in these with blocks. It's a little weird syntax, but that's what it is. And then whenever you're processing a result, you have the await keyword. So how does this apply potentially to DevOps and websites and so on? Well, there's many examples, but what I've been using it for lately that I think nobody would guess about is to get this. Page speed insights is something that comes from Google. It's under this code name Lighthouse. And what it does is it tells you how fast clients, not your server, but how fast web browsers out on the internet perceive your site to be. You want that to be as fast as possible. As you can imagine, 100 is good, 20 is bad. But what's really interesting is Google has started using that number for search ranking. Okay, so you want that number to be really, really high. And when I first threw my site into this, the various pages I was testing and whatnot, TalkPython, Python Bytes, training.talkpython.fm, all these, it came back and it said it was 52, moderately to borderline too slow, like not good. Not danger zone bad, but not good. So what are we gonna do? Like, I thought my site was fast. Like if I go to the server and I look at the MicroWhiskey logs, it says this page was rendered in 7 milliseconds. This page was rendered in 12 milliseconds. This slow one took 40 milliseconds. Those all seem incredibly fast to me, right? Like that's slower than ping time. Who cares? How much faster do I need to make it? But there's a lot of other factors at play. If you put, let's go ahead and just pull this site up real quick here. So like if I go and I put this, again, something like, let's say, Ars Technica, right? That's a site that seems pretty decent. It turns out this site needs some serious consultation on this, as you'll see. But here's the thing. There's all these different things that it measures. It measures how fast does the server respond, how fast is the JavaScript rendered, do I have to resize the image? Look at this. This is bad. They don't want that. So there's a bunch of things, and their server is actually fast enough, but one of the most important things is, does the server actually respond in time? And what I found was, if I do a new deploy, there's like hundreds of pages on the site, and each one of those takes like 2 seconds the first time it gets hit. And then it's really fast, like I described it, but there's like parsing of the HTML, Python templates, and all the kind of sort of startup stuff, and then it's super fast. And what was really concerning to me as well, what if I do a deploy and then Google indexes my site, sees this 22, this is not my 22 by the way, sees this 22 and says, oh, this site sucks, we're going to downgrade it in ranking. So I went about using Python to make my site ready to receive all of the requests from the second that I turn it on. So if I do a deploy now, the very next step before I even like move the server back into the production, into the load balancer scenario, is to run what I'm going to show you against it to make sure that what we get is something better.
We have members in the audience oohing and awing over your 100. They're very impressed.
Awesome. Let's see if I can recreate it live. This thing is super finicky, so you could easily see like a 10-point gap. So 43 on mobile is pretty good, and yeah, 100 on desktop. So pretty good. 43 on, or 93 on mobile is also not shabby, right? Compare that to Ars Technica, which is a pretty pro site. It's getting like a 22. That's, somebody needs to talk to them about that. So, however, though, I'll let you all inside the circle here, as in, let's go over there and let's do some damage on this thing. So if we come over here, and what is the command I was running? Here, I set up, not that one. I think this is the one. That's the one. Okay. So I'm going to do a shortcut of what a deploy looks like. I'm just going to take the server out of the production loop, restart the web app, restart Nginx, and then go online. And before I do that, let me actually jump back and say what we're going to be trying to solve here real quick. Let me draw a quick picture of the architecture here. So I have Nginx and MicroWhiskey running, and it looks like this. We have Nginx, we have MicroWhiskey, but MicroWhiskey is the thing that runs Python. Python is not normally good at handling multiple requests. If something's hung up, you want to be able to continue processing other things. So what this actually runs is in like the supervisor mode, where it runs Python in a bunch of little sub-processes. On my infrastructure, there's 10 of those. A request comes in over this. Nginx is what you believe the server to be when you talk to it. Internally, it's using either sockets or HTTP or even HTTPS, I guess, if it wanted to talk to this supervisor bit. It says, okay, this one can handle it now. Another request comes in and says, oh, this one. Yet another request, maybe this one. So in order to get this thing ready to go and score 100 on the page insights, you need to make sure every one of those worker processes has tried to load that page, yeah? You could issue a ton of different requests to this thing and hope just randomly that they've been sort of fanned about. Or you could just say issue 10 requests if you have 10 worker processes, and you'll be, if you do it at exactly the same time, MicroWhiskey will have to fan them out to all the other ones because some of them will be busy, so it gives them to the others, right? So that's how we're going to use async and await. We're going to make sure that all the pages get requested at least once before we put the thing back into the load balancer. Yeah? All right. So if I do this, do a quick, you can see it takes it out of production, out of the production IP, does some restarts on it. Now that's all done. Now it switches it back. If I'm quick enough, I should be able to get this to give us a less good answer. Like I said, it's finicky, but I'll show you some bad numbers for sure. Fingers crossed for something bad. Didn't do it. It was too quick. Either somebody hit that page or whatever. But let me show you something that I built over here called Wakeup. So this is a little package. It's on GitHub. You can actually pip install it and run it on your servers. It works really, really well. So the idea is what we're going to do. We're going to come, where is this thing here? We're going to come and you're going to pass us way down at the bottom. You will pass us somewhere where the arguments, sorry about that. Here, you're going to pass us a sitemap. So a sitemap is a XML document that says all of the pages you have on your site. So for example, wait for it. There you go. So we've got the root page, we've got courses all, we've got the business page, policies, etc. Like this is a huge document, right? You see the scroll bar? It's very large. So what we're going to do is go through and request every one of those pages with some shortcuts for stuff that's kind of the duplicate. And the way we're going to do that is somewhere over here, down further. Look at this. Async. We're going to go async and get all of these URLs and kick that off, and then we're going to wait for them all to finish. And down here, the way it works is we actually want to keep track of the time because we report that. Go and make a request to that page. And what we're going to pass to this is actually the sitemap and the number of worker processes. So over here, but one can spell, you can see we have all these worker processes running. They're chilling in the background. And you can see these 4 processing requests, well, Nginx and 2 of them. But notice they're like, doing a couple of requests and some are hanging out. So what we want to do is figure out how many there are. We set this up so we know there's 10. And then we're going to issue a bunch of requests to it. So the way we're going to do that is we're going to go and call Wakeup, give it the sitemap, the number of worker processes, and it turns out there's a ton of transcript pages, but they're all on the same basic template. And so you request one, it's just a different bit of data coming from the database. So instead of requesting 1,500 of those, let's request 1. So this is a little bit slow, so I'm going to run it once, and you'll see it's going over using just what we wrote. It's testing 34 URLs. And you can see, look at these results. This first one I hit a few times, so one of them was really fast, 160 milliseconds. But the median time was 4 seconds. Seconds, not milliseconds, seconds. Look at all these numbers. These are really bad. And that's because I just deployed, quote deployed. I didn't do all the stuff, but I just triggered the effective behavior of a deploy by restarting those servers, right? So I don't know about you, but if the median time or even the minimum time of my page loads is 2 seconds, like these numbers will definitely trigger a very bad either behavior from like a response from the user or ranking on a Lighthouse or PageSpeed, right? It'll say one of the biggest problems with your site is that the server response time is too slow. All right, now this takes a second, so I'm going to let it run through here, and I'll just come back to this. So this is super easy to use. You just install it onto a Python environment, pip install --user. It's not in PyPI because I'm not sure I want to have to take that much care of it, but it is available on GitHub, and I'll show that over here. The reason I'm coming to this is I want to let that thing run. It takes about 30 seconds or so, and we'll come back to it. All right, so if we use Python's async and await, we can make a request to every one of these micro-WSGI things, make sure for each page it's ready to go, and then we'll have incredibly better, as we'll see in a second, response time out of the box. That means our users have better experiences. That means if Google happens to come along and index it, Google gets its best possible outcome for that and things like that, okay?
Quick question.
Sure.
I presume the question is, I presume the sitemap is auto-generated? Question mark.
It's driven out of the database. Yeah.
Okay.
So it doesn't matter if the site map is fast. By the way, it's medium fast. It's got to generate like thousands of XML nodes. So it's kind of sluggish. It probably takes a second or something, but it's not requested very often, so it's fine. But yeah, it's just the site knows, here are the course pages, here are the transcript pages, here are the marketing pages, and it just, does like a loop out of all the ones it finds in the database.
Gotcha.
All right. So here's the source code. We're going to come back, and we're not finished yet, but like I said, I'm just stalling to make sure that finishes because I want to show you the result afterwards. So if you want the first bit of code that I wrote with the hitting and getting the title off of talkpython.fm, you can just visit, there's this webcast I did all about async and await over here. If you go to code and then the web scraping section, it's just right in there. You can grab that. If you want this little Wakeup utility, you can just pip install and you give it the Git URL. Like there's a way to say pip install with directly from a Git repository. You can just install that on your server. You can clone it, make it be yours, or you can. What I'm really expecting is that you can use this for inspiration for other types of things, kind of like this, right? Like, hey, I want to actually make all of these, like run this Ansible script against all these different places at once, or copy these files with SCP all at once. I don't know, right? There's a bunch of stuff that you might be doing. This is just one of them. All right, let's see how are we doing over here. We're done. Okay, notice all these times. These are terrible, right? 5.8 seconds, 6 seconds, 6.3 seconds. If I run it again, it will hit the same stuff, but after it's already gone through this process. So watch this. Watch how it changes. This is the new behavior of the site after the deploy. Look at that.
Boom.
Those are like 40 milliseconds, 60 milliseconds, 8 milliseconds. Right, the site is incredibly fast now going through that simple process of making sure we hit every micro WSGI worker process for every major section of our site that has its own template, basically. So hopefully that's useful to you all. And like I said, hopefully that's inspired you to think of some way to use async and await and the simple concurrency to do things that maybe would have otherwise been hard.
Definitely has given me a lot of excellent ideas to start monkeying with, especially the wake up routine. I'm going to definitely fork that and play with that.
Yeah, please do. Yeah, it's there for you all to take and do whatever you want with.
Cool.
All right, yeah, so if there's any questions, we have a little bit of time left for Q&A. When you look at Python, it's supposed to be nice and clear, but it's kind of like you need glasses. And you're like, oh, what is this? Consider taking our classes, and it'll help clear everything up for you. So, yeah, let me go.
I can second that. I'm currently in I want to say exercise number 4 of your 10 classes
But Jumpstart 10 app course, yeah.
Yeah, your Jumpstart 10 app course, and I'm super enjoying myself. I will admit I did install PyCharm. You've been effusive in your love of PyCharm, so I went ahead and threw that in there and started playing with that as well. I was a VS Code junkie, but now I'm playing with
VS Code is great, but I still think PyCharm has a slight edge, especially for people who are new. I think it helps a little bit more.
Yeah, and I'm super new. I mean, I'm like literally still playing with the REPL and doing stuff in idle and whatnot. So my exposure to the higher end stuff hasn't been, I'm not there yet. But PyCharm definitely has a lot of widgets that I'm afraid of playing with.
For sure.
But yeah, I can second your recommendation for your classes because they are truly excellent.
Oh, thank you, Chris.
Yeah, absolutely. Cool. I'm sorry, I interrupted you. Please go ahead.
I think I'm done. I'm going to leave up these links here for people unless there's a question where I need to pull up something. And actually, I'll pull up one more thing for you. Just one more time. Just revel in the glory. I mean, look at those times.
Yeah, and I'll definitely have all of the links in the show notes as well. Everything that you've had on there, I'll definitely be putting in the show notes.
All right, super. Yeah, so this little utility, you can just use the utility. You can take it and use it against your site. Like I said, it will work for anything that has a sitemap. You just need to know what is the right number to put here for how many concurrent requests to make to it in any like series of patterns, one after another of things to like only request once, like this, rather than for every 1,500 lectures or whatever, because that would work, but it would be wasteful.
Very cool. Nice. Thanks a lot.
Yeah.
Cool. All right. Let me do one quick scrape of the tweet deck. Make sure that nobody's posting to LATAM for some reason. Some people have been doing that recently. Nope. No, I think we fielded all the questions organically as we proceeded. So that was fantastic. Thank you, Michael. That was really fun.
You're welcome. Hopefully people don't let all the talk about how hard concurrent programming is scare you away, because I think async and await and this unsync library make it actually quite simple to achieve small little things. I mean, sure, really complicated stuff is still really complicated, but like small little wins like this become almost the same as writing just traditional code. So it's a lot of fun.
Very cool. All right. Yeah, we're getting some thank yous from the audience. Job well done. Thank you, sir. Richard Boyd has said thanks, Michael. Hi, Richard. Richard's one of my. Actually, I think you two might know each other. Richard was at PyCon. If not, I'll definitely make sure I introduce you two the next time that we're all in the same room. Cool. All right. Well, again, thank you very much, everybody. We will be continuing our series on Python next week. So we'll see you all then. And Michael Kennedy, thank you once again for coming on. It was a pleasure having you.
It was a pleasure being here. Thanks, and bye, everyone.
All right. Bye-bye.